Okay, guys, so let's continue. So yesterday we have discussed just a bit about GetVPN, and we have discussed about private network. Like GetVPN, we always use over the private network, and which private network we have to use, like a MPLS. Okay, so uh, GetVPN. So in GetVPN, we have some important components. Like one is key server. Okay, this is known as key server. Then we have a group member, which is known as GM. This is about a group members or group member only, you can say. And then we have a protocol that is the third is GDI. Okay. And the fourth one we have hoops here. Okay. So we have in one network, we have always one key server. Okay. And in case if you want to use it just for a backup as a kind of HA, so you can just add the another KS. That's it. But at the same time, one KS key server would be active. Group member is always equals to n minus 1, total number of devices minus 1, that would be equal to group members. This is a protocol, and this is again HA concept. So when we would go, this is HA protocol. Okay, so when we would configure HA, okay, in the KS servers, okay, so that time we have to use a protocol, and that protocol is known as COOPS. Okay, so these are the some get VPN important components and how does it works. So yesterday we already discussed over the private network we have to use. Okay, so this is like uh get VPN we have to use over the private network. And along with that, it would provide us one important thing, which is IP address preservation. So the second point we haven't discussed, so that we will discuss. Okay. So, but before that, let me start how exactly does it works. So let's consider this is a router which would act as a key server. This is we have ISP or any private network in between. Consider it. And this is group member 1, and this is group member 2, and this is the group member 3. So this would act as a ISP. This is key server, and this is group member 1. It will act as a group member 2, and this is a group member 3. Okay, let's consider this IP is 11.1. This is about 12.1, 13.1, and this is 14.1 here. So on ISP, we have .2 IP. This is all about .2 IP on all the interfaces, and we have proper reachability, everything. So reachability would be provided by MPLS. Okay, so we have to configure MPLS, but instead of MPLS, now I'm going to be use the EIGRP because this is just a training mode. So that's the reason I'm going to be use EIGRP. But in the real corporate, we have to use MPLS always. Okay. So now, so first thing, you have to make sure there must be reachability between both the devices, between all the devices. So this is the key server, okay? And on this key server, what we have to configure, we have to configure here as a CAM policy. We have to configure here transform set, and we have to configure here access list, and then GUI group. So in the configuration, we have to configure all these things. What does it mean? So see, when we will configure a GUI, what is the concept about GUI? In the GUI, okay, or you can say the get VPN, we have two keys actually. What we have? Two keys here. One we have tag traffic encryption keys, and second we have CAG, which is key encryption keys actually. Okay, so this is the concept. We have tag and CAG here. So which is very important concept here, which is tag and CAG. So this is one is tag and second is CAG here. Traffic encryption. The first one, this is we used to encrypt the traffic, or you can say the actual data. Okay, this key we use to encrypt the actual data, or you can say the traffic. Okay, this is CAC. So now this key we use to encrypt the during the key process. Yes, the statement is clear. What is a rekey, that I'll explain. Okay, but first tag we used to encrypt the actual traffic, which is the data, and the CAC is about the encryption, which is for the we used to encrypt the tag during the rekey here. Okay, so overall concept is behind this group member and behind this we are using one loop back here. Okay, we have a loop back here, we have a loop back here, and we have along with that we have a loop back over here. So this loop back is 1.1.1.1. This is about 2.2.2.2, and this is about 3.0.0.3. Okay, now, so overall concept is like, one second. Guys, we have so many terms into this. If you have any doubt, any question, just kindly ask me immediately. Okay. Now, so this is the loop back here, and this is another loop back, and this is a loop back here. So, like your DFVPN, what we have to do it in the between the, or like a CS servers, we have to configure one IPsec tunnel between these devices. Okay, and then we have to exchange the data of with the within this loop backend, with this loop back, with this loop backend, this loop back, because these loop backs are your LAN network. Okay, so this is a LAN of this site, LAN of this site, and this is LAN of this site here. So you can consider this is site A, this is site B, this is site C, this is the LAN A for this is the LAN B here, and this is the LAN C we have here. Okay. So this is, otherwise I'll mention here, this is a site A, this is site B, and this is site C. So this is a LAN A, this is the LAN B, and this is the LAN C. Okay. Okay, this is about your headquarter, main branch office. Okay. So see, what is the overall concept? The overall concept in the end, what would be the verification? The verification is key. We have to exchange the data between this LAN and this LAN, or between this LAN, and that must be in the secure manner. In DMVPN, we have seen, okay, we have configured tunnels there, but we have seen in the DMVPN if this device has to share the data with the site A has to share any kind of data with the site B, it was using a different keys. If this site has to share any data with the site C, so it was using the different keys for encryption and hashing. For example, site A to site A to B data transfer, it was using the keys. Let's consider 1, 2, 3. Then site A to C, if it was exchanging any data, it was using the different keys 4, 5, 6, and same with from site A to, let's consider headquarter, okay, or might be any other site. So it was using different keys, which consider 5, 6, 7 here. So that time we had to manage, okay, multiple keys on one side. So this is the same for the site A, same for the site B, same for the site C, and each and every sites they were using different keys to encrypt and decrypt the data for each other. Okay, but this time we have a centralized key management concept. We have centralized key management here. So in this, what happened? In this key, centralized key management, what is there? This key is going to be remain same on all the devices. Means from the key server, let's consider this is group member. So this group member, we have to register with the key server and then we have to download the keys from there. Okay. Key server would generate one tag here. Tag key, let's consider tag is 123 and then CAG, which is about ABC. So what happened? When the group members would register like a CS server, on the CS server time, I hope you remember guys, we used to register our CA clients with the CS servers and we used to download the certificate. So that time we were just downloading the certifications only for authentication. But here, authentication would happen between the devices directly. But after that, what will be there? The keys would be downloaded, okay, from the key server to the these devices, which we are going to be used for encryption and hashing. Okay, so this is the tag key, tag and CAG. Tag, so I hope this is clear why we use, which is used to encrypt the traffic here. CAG I'll explain. So right now, kindly focus on the tag here. But I'll just mention here ki when the group member would register, and group member has to register themselves with the key server, and after that from the key server they would download the tag and CAG keys. So this is the tag and CAG, and this tag and CAG is going to be remain same on all the group members. Okay, this is going to be remain same on all the group members. So what happened next time? Let's consider right now they have downloaded tag and CAG from the key servers, and after that group member 1 and group member 2 want to establish a tunnel, or let's consider they want to exchange any data. Okay, so they are going to be use this key to encrypt and decrypt the data. Yes. So overall, for encryption of the data and for the decryption of data, they are going to be use which key? Tag key. And tag is the common key on all the devices. So the devices doesn't like they doesn't has to manage okay different keys for the different sites here. So we are going to be use a common key for encryption and so common key for encryption and hashing or for hash of data on in all of the device at we can say all the sites. So this concept is known as centralized keys concept. Okay, and which key we are going to use for that? Tag keys. Okay, so on the key server, we have to define as a camp policy, we have to define transform set, we have to define an access list, we have to define G2I group. And same on the group member, this is the configuration of key server. After along with that, we have one or two more configuration into that. But if you would ask me about the key server, sorry, on the group member, what we have to do it, we have to just as a camp see here. Okay, there would be as a camp policy, and after that there would be authentication key we have to define. That's it. After that, and registration with key server with the via G2I group. Okay, this is the one step here, and that's it. That's it, yes. This is the concept here. Okay, so we do not have to define any kind of access list, even access list here. So what are the two important things here? One is the keys. Okay, and this is the transform set and access list. So these things would be downloaded from key server to the group members. These things would be downloaded from where? These things would be downloaded from the key server to the group members. Okay, so as a network admin, I would have like I'll have the full access on my all the group members in the network here. So whatever ACL I'll define here, okay, as per that network only, they would encrypt and decrypt the data. So let's consider behind this there is a LAN E here. There is a LAN app, another LAN. This is another LAN, and I do not want to uh like encrypt the data between these LANs. So no worry. So here in the ACL, I have to define only these access list. That's it. Okay, because you cannot define access list in the IPsec configuration on these devices here. You have to define always on the key set. So this is the concept about the get VPN. Up to here, guys, is this clear or not? It's not completed. So just the first part is completed or not? Any doubt, any questions, anyone? Yes, guys. Any doubt, any questions? Yes, someone was asking something. Clear? I think someone was asking.
No, I'm telling that. Clear,
Okay.
sir.
Okay. Now, after this, we have the concept about re-keys. Let's consider we have downloaded the keys on the tag and everything here. Tag and CAC we have downloaded, and now we have to like the question is for how long these keys are valid here. The question is how long these keys are valid here. So answer is tag is for 1 hour and CAC is for 24 hours here. And you can just change the timer also. Okay, when we will, so I'll show the practical. So that time I'll make it even tag as a 300 second because 300 second is the minimum time. So this is the minimum time. Okay, so this practical we'll see tomorrow, but still I have to give you the theoretical idea here. So let's consider what is there. This is the tag and which is like now about to expire here. In depth about this one, we will talk about tomorrow, but brief idea because today in the starting itself, practically we have so many things. So this is the tag here. So in the tag now the question is ki Amit, 1 second, tag. So let's consider the tag. Tag is going to be expired. So now again rekey would happen and this key server has to rekey. So the question is Amit, as a group member, shall I ask the key server again for the another key or automatically key server would send it? Okay. So the question is, as a group member, shall I ask it again for the new keys or like will this key server would send it automatically? So this is now guys, key server responsibility. This is the key server responsibility and key server would send the new tag key to the all the group members automatically. So now we have a very important concept here, which is known as rekey. Rekey of which one? That is the tag, traffic encryption. So here that can be happen via two ways. One is unicast and second is multicast. Unicast is where we receive would receive the acknowledgement from the group members. Okay. After after receiving the tag from key server. Okay. Multicast, there is no acknowledgement from group members. Okay. So by default, it's always multicast. And if I talk about which is enabled by default, it's always multicast. This is multicast would be as a by default. By default. Okay. So now, so the concept is this is the key server. Okay. And from here, let's consider we have made a timer 300 seconds for this one. Tag is 300 seconds. We have downloaded the keys here. Okay, now almost 3 minutes is over. Okay. So after that, if in case if you are adding a new group member into this, so this group member would receive the, because this group member has to register himself with the key server and would receive the tag keys here. So when this tag would be received, so for it would be valid for another 2 minutes only. It not would be valid for the another 5 minutes because the timer is common here. Are you getting my point, guys? Because 3 minutes is already over here, and if you are again adding a new key server group member into this, so this group member has to register with the key server, and this key server would share the tag keys, and which would be valid just for another 2 minutes. Because after 5 minutes, what would happen? Rekey would happen. And after that, again, this device also would receive the new rekey. Because we are using a centralized concept, so centralized timer would work here, not the individual timer. It's not like that. This group member says, just I have registered myself with the 2 minutes back only, and total timer is you have set it 3 minutes. No, or 5 minutes. So my again 3 minutes are pending here. No, it's not like that. The timer is always centralized. So if key server timer is going to be expired, because timer would run here 300 seconds, 299, 298, 297, 295, like that. Okay. So here rekey who would initiate? Key server would initiate automatically. How many seconds before? 90 seconds before expiring the existing key here. Sorry. Okay, so the key server would initiate the rekeys. Okay, how long before? 90 seconds before expiring the existing tag. Okay, how that can be use any transport medium, unicast or a multicast. That depends what you are using it. Practically, we would check both. Okay. So along with that, this is the during the rekey, this is the transport medium. Along with that, the key has to encrypt also. Okay. So what here? So during the rekey, during the transport, during the rekey process, when key server would share the new tag key with group members, so then encryption of tag would happen. Means when a key server would exchange with the help of CAT. Okay, so let's consider this is earlier tag here, and now this group member has a generated new tag. So this is new tag, and new tag is about, consider AB. This is about BCA. There's a new tag and it has to retransmit to the new group to the group members. So now which transport medium it's going to be used? It can be unicast or multicast. Let's consider I'm using here unicast here. But during the transport, okay, this key has to be encrypted. So then this key would be encrypted here. Question is, with the help of the which key is there? Okay, because during the rekey, we have some configuration, and in the rekey, we have to define during the rekey which encryption algorithm we have to use it. The algorithm is 3 dash, and which keys we are going to be used? We are going to be use the CAC. CAC is not need to define, that is by default. So because this key we are just using for what? Just to encrypt the keys only. Okay, so this is the key which we are going to be used to encrypt and decrypt the tag. Okay, so we have a common CAC on all the devices. So this device would encrypt it, okay, and this device would decrypt it once it would receive, and after that there would be a new tag which is about BCA. Is this clear or not?
Excuse me, sir.
Yes, please.
Why this happening, sir, this rekey concept?
Because say if same key will be there for the long, there would be possibility key hackers would sniff it
Okay.
for the security purpose. Like in IPsec also we had after 24 hours we used to reinitiate it. So this is the same concept.
Okay, sir.
Yes, other students, any doubt, any question?
Excuse me, sir.
Yeah, tell me.
That is
You are
used to encrypt that, right?
you're not no, you are not audible. Just properly just check your mic once.
Hello, sir. Sir, am I audible?
Yes. Yeah, just tell me.
So this cache is used to encrypt the tag, right?
Sorry.
Hello.
Yes.
So this tag is used to encrypt the tag key, right?
Oh, see. The tag we use, what is a T? T defines traffic here. So, guys, let's talk about IPsec. In IPsec, in the Diffie-Hellman, you remember we used to exchange the keys, keying material, right?
Yes. Yes, sir.
So the same keying material. And who is generating it? Key server. We are not using Diffie-Hellman here because key server is not negotiating with anyone. Okay, so we have to generate this key. So that is tag. This key which we are going to be used to encrypt the data. The tag is clear now, Santosh also?
Yes.
Tag is the key which we are going to be used to encrypt the data. Okay, so see. Yes, no problem. See, as I told, so many concepts we have, so don't worry, one by one, because this is right now theoretical I'm explaining. Okay, and along with that, I'll show you the practical. That time also I'll explain here, but I'll again give you the brief idea. So see, the first question, we have to configure a tunnel here. Okay, and via that tunnel, let's consider this is I have to configure a tunnel, and via this tunnel I have to exchange the data, correct? But that data should be in the encrypted format. And when you for encrypted data is fine, but after that we need to define here what, which algorithm. We have to define here transform set, right? Which algorithm I'm going to be used to encrypt the data. And after that we need a keying material. And usually in IPsec, we refer it from the where? From the phase one. Is this clear or not? Yes, guys.
Sir.
You can just turn on your mic, okay? And just acknowledge it. Okay. But after that, yesterday we have discussed PFS. In case if you do not want to use the same keys here, so you can just exchange in the phase two, and for that you need to enable the PFS. But today, the concept is this says it's not in the hand of like group members कि they can exchange any keys here. No transform set you can declare here, no keys concept here, and not even about the access list. Who will manage all this thing here? Key server would manage it. Key server is saying you just wait. I'll only generate the keys and I'll share it with you. You have to use the same keys to encrypt the data there. Because this is I'm using over the private network. So this is high-end security is not required for this. Are you getting my point? High-end security is not required over this here. So what I'll do it, I'll just make a centralized concept here, and as per the centralized, I'll only generate the key, and those keys only you have to use it. Clear? So what is that key? That key is known as tag. Clear? It would send it where? Send it to this, send it to this, send it to this here. Do one thing, do not think about CAC. Now you just tell me, tag is clear or not? So tag is the key, that is that keying material. Okay, earlier we used to exchange in the phase one, and this is we are going to be used to encrypt and decrypt the data. Yes, Today, the what is the extra thing we have? The concept is key. Today we have same keys actually on all the sides. Earlier it was different. Okay, earlier it was different between this to this. Earlier it was difference between this. Earlier it was difference between this here. So today it's common. So this is called kind of centralized key management we have. Yes, guys, is this clear? Santosh has acknowledged. What about other one guy who was asking? I think Pawan was asking, right? Or Saran?
Yes, sir. It's clear, sir.
Clear? Now, the second concept is, Amit, what is the meaning of CAC? The CAC concept is, see, when this key is now valid for, let's consider I have made a timer as a 300 seconds, which is common on all the devices here. This timer we have to set actually on the key server. Okay, but from there it would be downloaded here. And now this is valid for how long? 300 seconds. So after 300 seconds, we need a new tag key or not? Okay, but group members cannot generate it. Only who can generate it? Key server. So now the key server has to share new tag key here. So this, when this key server would send the new tag, that concept is known as rekey. Clear or not? The process of sharing, the process of sharing new tag is known as rekey. Now, guys, I hope this is clear. The statement is also clear.
Yes, sir. Yes, sir.
The question again, you see, Amit, when we are sharing this tag again, or when this key server would share the tag again. So over that, what? This is not ISP. We are using SP here. SP is about what? MPLS. So blindly, na, I cannot trust Orange. Ki might be they would sniff my this tag key. And if they would sniff my tag key, so obviously they also would be able to decrypt my data or the data between the group members, whatever they are going to be exchanged. Correct? So key server is thinking, okay, when I'm sending or when I'm doing the rekey here, so this new key, let's consider my new key is what? My new tag is what? 896. So this new tag also has to encrypt. Means when I'll share with my group members, this also would be into the which format? Encrypted format. Is this clear or not? So this time it's going to be encrypted with the help of the which key? The key is going to be used CAC here. The key encrypted. So this is the key which we use just to encrypt the tag during the rekey process. So that time, and they have also tag here, CAC, sorry, they have also. So this time we have to share the CAC also with them. So now in the role, which key is there? CAC here. So now this is clear. So encrypted tag, new encrypted tag would be shared by the key server, and then that would be decrypted with the help of the which CAC, which is already present at the your group members, which we have shared earlier. So now is this clear or not?
Yes, sir. Clear.
Okay. Sushil, it's clear. I think you were asking about the rekey process, right? Yeah. Okay. So in the rekey, we have some timers. The timer, I'm not sharing it right now. Okay, because that I'll share during the practical, and tomorrow only we'll do its practical, not today. During the initial registration, the first time where we would register. Okay, so tag and CAC both would be downloaded on the group members. Okay, so I'll start with the practical here now. Even I have to explain IP reservation and all, one more topic, but I don't want to get into theory right now. I'll start with the practical. So along with the practical, I'll show you. Let me just start it. So we have so many commands into this. Okay. Command perspective, there are a lot of commands here on the key server. 1.14. Let me start all the devices. This is another key server, which is for the HA concept, like in Dual Hub we were using, right? Dual Hub concept in the DM VPN. So this is, we will use it later. So just now, meanwhile, what we'll do it, we will configure its configuration. Okay. So because it will take some time, or I think might be some configuration will be pre-configured only. The basic configuration will be there, I think so. Let's wait, let it be start. Because I think I have saved it last time, because basic configuration means what? What here? The basic configuration means their IP addresses. Okay. So for communication, I'm using here instead of MPLS, the private network, I'm using which protocol? I'm using here EHRP. So EHRP I have configured. So I think they are able to communicate with each other. So let it be start. Just wait for 1 or 2 minutes. Okay. So group member 1, group member 2, group number 3. So let it be start. Meanwhile, let me open its document. One document which I was using yesterday. PPT. So this is the first step for the group member to register to the KS in order to do ISACAP to establish between the group member and the key server. Then this is the initial communication and all. Okay. So I'll take you here directly to the. So these are the steps which is in the key server configuration which we have to define. Okay. This is the configuration. One by one, we will define it. So this is the upper one. This is all about the basic configuration. So from here, we have to define. So we have to define what we have to define here. Okay. So if I'll compare key server configuration with the group members, in meanwhile, let's my devices start. So crypto ISACAM policy 10, encryption 3 dash, hashing MD5, group 2, authentication, pre-share, exit. Crypto ISACAM key, Cisco address 0.0. Because group member has to authenticate themselves with the key server. That's the reason I have mentioned here 0000. And this is also this configuration is going to be remain same. But after that, all the configuration would be on the key server side. So then on the key server, we have to generate one key here. Okay. Crypto key generate RSA. Our label Cisco modulus 1024. After that, crypto IPsec transform set. So this is here. Our crypto IPsec transform set. Name is T set here, ESP 3 dash ESP MD5. Okay. So this is I have to define here. Then let me take the exit from here. After that, I have to define access list 101 permit IP. 0.255./8 I'm defining here, and then 10.0.0.0 0.255.255. So this is the access list which I have to define here. Okay. So we don't have to define any access list on the group number. So this is the access list. After that, I have to define crypto IPsec profile. The name is IPsec here. Set, transform set, tset, and exit. This is the configuration. Okay, but here we do not have to define any kind of configuration, which is we have done here. Okay, everything would be downloaded from the e-server. After this, we have to generate here crypto group, crypto GUI group. The name is CCI. This is the group name. I have to define identity number here, 10, which must be same on all the devices. After that, I have to define local server. Okay, the same device means same device I'm using as a key server. Okay, so after that, we have to define some other configuration also, like for the rekey and all. In case, can we turn off your okay? So this is the see, first of all here, our crypto mapping. Sorry, this is ISACamp here. Then we have to define authentication key, generate a key here, transform set, access list, IPsec profile. After define, create a GUI group. This is here, and then we have to define the rekey concept here. So how rekey would happen? Okay, for during the rekey, one authentication will be there. So I'll explain during the practical, during the okay rekey algorithm, transport, and all these things we have to define. Here in the last, we have to just define here crypto GUI group. Name is CCI. Identity number is 10. Server is, who's the server? 11.1.1.1 is my server. So this is my key server. Okay. Then client registration. How to register with which interface? Whatever the interface we're using. After that, we have to define one crypto map. Crypto map. IMAP here, 10. So earlier we used to use IPsec and ISACamp. I hope you remember this for the command, but this time we have to use here GUI. Okay, so that's it. And after that, we have to define here group and all. So once or two small commands. So this is command perspective is totally different. So just let me check it out. It has our key server here. So I think the page brief. Ping with 12.3 and 13.4. So 12.1.1.1.3. Okay, I'm able to ping with 13.1.1.1.4. So let me just check with this. Okay, configuration itself is not. So what about this device? Is do I ping the page brief 14.2, that's it. Okay. So just I have to configure it. Okay, and just let me check one more thing. Which protocol are they using it? They are using ARP10. Fine. Okay. Now the post name is group number 3. Interface 0/0. IP address 40.1.1.5 here /24. No sure. Thanks. Okay. Now, along with that interface Go back 0. IP address 10.5.5.5.5. Ping with 11.1.1.1.1. Able to ping with 12.1.1.1.3. Able to ping to the group number 1 and 13.1.1. So guys, configuration perspective, I hope this is clear. Okay, we have just configured. Okay, and just an EIGRP. If you know MPLS, you can configure MPLS. But overall, there should be one thing. There should be reachability between the key server and all the group members. Yes, is this clear? Yes, guys, up to here, is this clear? Is there anyone who has any doubt, any questions, anyone? I hope all clear, right? Okay, so let's start it. So, configuration perspective. This is the key server configuration, and this is my key server here. And let me just define. Show crypto GUI. Just check it. Is there any GUI configured? No. Okay, so otherwise it would have show you the config, like the details if it would have configured. So now define the configuration here. Crypto as a CAM policy 10, encryption 3 dash, hash about MD5, authentication, pre-share, group we are using. Okay, the crypto key, as we told, we have to generate RSA, label, Cisco, and modulus 1024. After that, authentication, crypto as a CAM key, Cisco address 02020, because this is it's unable for all the group members. So I cannot define here for the one. If you want to define, then you have to define multiple times for the first group member, then for the second, then for the third, then fourth. So 00 means this is open for all here. Crypto IPsec transform set T set here, ESP 3 dash ESP MD5 here. Crypto IPsec profile name is IPsec here, set transform set T set here. This is fine. Access list 101 permit IP 10.0.0.0. I'm using here /8. /8 only I have defined here. Okay, as a source, also as a destination also. Okay. After this is the important. Up to here, the configuration is very simple. This is which we have done multiple time. Okay, during the earlier configuration in the earlier classes. Okay, we don't have any new configuration here. So right now the new configuration is what? Which one? This is the GUI. So now let's start with the GUI configuration. Okay. So now crypto GUI group, the name is CCI. It can be anything, but in CCI lab exam, as a task, you would get the same name and you have to use in the caps only. So in case of Cisco has asked you to use the name in the caps, so you have to use name in the caps. If they have asked you in the small letters, then you have to use the small letter here, because these names are always case sensitive. In the context of marks. Okay. So this is one. After this, I have to define here identity number. This is the range of the number. This number must be same on all the group members and all the key servers. So let's consider I'm going to use that. Server local I'm a server, that's the reason. And you can see G2I is on now. Group. This is what? This is group here. And the moment I have defined server local, I have entered into which mode now? I have entered into the server mode. Okay, guys, is this clear? The use of these three commands is clear now. Local server, the same device I'm using as a local server. And now GDOI has up, or you can say it's on. Guys, is there any doubt, anyone, any questions? Okay, after these three commands here. Clear? Okay. Okay. So next concept we have here, Reiki. Reiki authentication. See, you know what happened? When Reiki process will be there, during the Reiki process, so first of all, key server is saying, when Reiki would happen and when I'll send the key to the devices here, so that time there should be one authentication must be there. There should be what? There should be authentication. The reason because just before delivery or before hand over the keys to the group member, I just want to be sure that yes, this key I'm sharing with the authorized person here. So that's the reason for that. What should be there? There should be one during the Reiki authentication should be there. So Reiki authentication, the command is my public key and my public key RSA, and which key we have generated earlier, Cisco we are using here. So this is the command where I'm defining authentication between key server and group members during the Reiki process, because I'm talking about Reiki here. Next we have Reiki and algorithms. So which algorithm I'm going to be used for the encryption? Because when once we'll start the process of Reiki, so that time it would be encrypted. So which algorithm I'm going to be use it? Let's consider I'll use here 3 dash. Reiki transport. It's by default, it's multicast, but I want to define it a unicast here. So I'll just mention it as a unicast. Okay, so you can see one message, one information we have. The G2I Reiki, the key server Reiki transmission or the transport, okay, which is unicast. Now this is defined to the unicast. So by default, it's about multicast. Now it's defined to a unicast. Okay, if you want to define multicast, remove this command, and after that it would be moved to the multicast. But I want to use for the unicast only. So that's the reason I'm going to use it as a unicast. Clear? So these are the things. Along with that, what else? So this is related to the keys here. So these are the three commands which is related to the Reiki process. After that, I have to define one more command here for the Reiki configuration. Because after this, now I have to define Reiki configuration. Okay, so in the Reiki configuration, first define your authentication here. Authentication key, then encryption key, then about transport medium, that is uni or multicast, and from where we are going to perform Reiki. So I have to define the address here, which device we are using this router and this interface, and what is the IP here, 11.1. So I have to define here address IPv4 11.1.1.1. So from this address, I'm going to be perform Reiki. Okay, so related to the Reiki, you have to define 4 commands here. Okay, so this is all about the Reiki process. So because in the crypto, because in exam, most of the students, they are always confused and they are always try to cram these commands here. Okay, so that is not a good idea. Just try to understand the commands. It would help you in the troubleshooting also. Okay, so this is the way how to understand it and how to divide these configuration into the different parts. So the first define about the G2I group, the name of the group, then identity number, define who's the server. I'm the server. After that, define the rekey. We have 4 concepts into this. And now, next concept we have to define here, what we are going to be encrypt and what exactly, what and how we are going to encrypt. What means which traffic? Okay, so which traffic, guys? That is depend how we would define the traffic here. If I'll ask you which traffic, so which traffic or what? So this is all about the ACL related. If I talk about how concept, so in that we have to define transport set here. So we have to define what? Transform set. But transform set I have already called inside the IPsec profile. I hope you remember. Transform set is about what? T set I have called inside the IPsec. So it means I have to call what? I have to call here now into how. Okay, I have to define here IPsec. Okay, so you can see in the comments here now. Okay, so SA IPsec1. So this is means okay what we are going to be defined here. SA IPsec1. And now you can say I'm inside the IPsec because IPsec is the actual concept where we are going to be encrypt the data and all, right? IPsec is the actual protocol. So into the IPsec, I have to define here match address 101, IPv4 101, and then define your profile. What is that? Profile IPsec. The command is profile IPsec. That's it. After profile, I have defined 2 things. After that, I have taken exit. Right now, I'm in server. One more exit, I'm inside the group, and one more exit, I'm into the configuration. Because crypto G2I group name C say right now I'm in G2I group. Server local, I'm inside the server now. I've SA IPsec 1. I'm inside the IPsec. So we have 3 modes inside that. Okay, so we have configured the. Any questions, guys? Any doubt? Anyone? I hope this is clear. So just try to understand the G2I configuration. Okay. Most of the students, they have always problem with the commands. Sir, there are so many commands. So no, there is yes, commands are there, but these commands are you already familiar. This is not a new command. You're already familiar with this. And this is what? Actually, yeah, new commands, but there is a way how to be familiar with these commands. Okay. So I'm just waiting for your reply. Any doubt, any questions, anyone? Yes, guys. Any doubt, any questions? All clear? Okay. So now we have to start with the configuration of group member. And the group member configuration is easy. Just you have to make sure the ISACAM policy, this configuration must be safe. Okay, so the configuration will remain same on all the group members. So that's the reason I'll just I'll do one thing. I'll just be back here on the group number 1 here. Now, so here I have to define crypto ISACAM policy tag. Before that, let's check it out here. So crypto. So these things must be same. That's the reason I'll copy and paste it. Okay. After that, even key also, that concept is also must be same. So which key we are using? We are using Cisco only, that I remember. Crypto as a cab key. Cisco address. So these are the two things which you have to define. First of all, you can see these are the two things which we have to define. After that, directly I have to define GUI group. Crypto GUI group name is CCI, identity number 10. Server address IPv4 11.1.1.1. Who's my server? 11.1.1. is my server here. After that, I have to define here client registration. Client registration. Question mark. Interface. Which interface is there? 0/0. So I have to define 0/. So I think this is the only configuration which is required on the group member, on the group member in GUI. Identity number, server, yes. So this is the only configuration. Okay. So then here after that, take a exit, crypto map IMAP 10 GUI. So I have to define this time into the GUI here, and it's saying this new crypto will be remain disabled until a valid group has been defined. So now I have to define here, set a group. The name of the group is CSI. So this CSI is the what? This is the name of my GUI group. Okay, so I have to define here set group name is CCI exit. After that, interface 0/0 crypto map name is IMAP here. That's it. So this is the configuration. This is the only configuration on ASIC on group member. So after that, interface 0/0 crypto map IMAP. GUI is on. You can see tag and CAC was updated. Okay, so first of all, start a registration to the key server 11.1 the moment when my GUI has on the group member here. So it's saying start a registration to the key server, which is 11.1.1.1 for a group CCI using the address here. After that, SA tag was updated. This is the CAC here, which is updated, and now registration has been completed and the key policies has been defined. Clear, guys? Okay, so show crypto GUI question mark. You can check here about what is the group name here. The group name is CCI, which I have only defined. Group identity number I have defined. Group type GUI I have defined. Crypto path and all. Who's the group server list? Who's my group? 11.1. Right now, who is my key server? Key server is 11.1. So we have a one key server. That's the reason I have defined. But in the future, we would add one more key server into this here during the HA concept. After that, you can see group member information for the group CCI. So IPsec SA in this in the both direction. ACL received from the key server. And which is the ACL here? GUI group CCI. So this is the ACL which we have downloaded from the group member, from the key server. So this is the information about key server. So this is the group member information. Who's the group member here? 12.1.3. This is my IP address. Are you using any VRF? No. Who's the local address? 12.1.1.3. And this is about 848. So what is the GUI group here, guys? What is the GUI? GUI protocol is about UDP and port number is 848. Let me enable the capture. So I'll enable the capture here because we haven't registered here. So this is, let me enable the captures here. Or let it be this, not this. Yeah, this is only. Okay. So this is, so after this, version 1.0.17, it's already registered with 11.1, registered. This is the key in 3600. This is the timer, and also these timers we will discuss later. This is the CAC here. This is that ACL gas which we have actually downloaded. You can see the ACL also right now here, which we have defined on the 11.1. CAC. So this is the transport medium is unicast. What is the live timer? This is the live timer. Encryption algorithm 3-. This is the default timer. We will change it. Okay. So key size and all. So this is that information. And this is IPsec assay, which we are going to, this is the SPI, which we are going to be used to encrypt the data. So this is just for the key server 1. So the group member 1. And now let me get into the group member 2 here. So section. So most of the configuration is same. So I can just copy and paste it here. This is about ISACAM, key, GDOI group, identity number, server, client registration. I can copy and paste it here. Up to here, copy and paste on the group 2, group number 2. So this is identity number here. This is address. Crypto map, it's fine. Interface 0/0. Crypto map. IMAP. This is also fine. Okay. And now again, up to here, copy, and let me paste on the third group member here. Page 0/0. Crypto map. All done. Okay, guys. For all the devices, we have downloaded it. So you can see the captures here. Port number 8. See, when the registration would be there between key server and a group member, we would exchange 10 messages. Like in IPsec, we had a concept about 9 messages or 6 messages, depends on the mode. After that, in SSL also, we had a concept about 10 or 12 messages there. And this time in Get VPN, okay, GDOI, how many messages we have? Again, 10 messages. Yes, you can define whatever, but then you have to define multiple commands over there. Otherwise, you can define whatever you want to do it. So just to, because I just want to make it simple. So that's the reason I have defined 0.0.0, or else you on group member, you can define that as a 11.1.1.1. Here you have to define 0.0.0. So you have two options here. One option is defined 0.0.0.0, which means for all, or else define 3 commands, one for the 12.3, one for 13.4, one 14.5 here. So from here you can define 0.0.0.0 also, or you can define for 11.1.1.1. It's your call. Okay. So we have 10 messages, guys, and as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So again, you can count it if you want to. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Port number 848. Okay. So we have user date this is, but this is about data only. So about this, I'll give you the brief idea tomorrow because we cannot capture that information into this because all about the this is all about the UDP and all we are using. So you won't be able to see any kind of header or data into this. Just only port numbers with the help of port number only we can define it here. That's it. Nothing else. You won't be able to see anything into this. Okay, that's not possible. Okay, so tomorrow I'll give you the brief idea about this. What is the meaning of for these messages here? But still, that much information is not available on internet and in the books also. Okay, but how many messages we have? We have 10 messages, which they would exchange during the registration process of group member and the key server. At which port number? Port number 848. Earlier it was ISACAM, which we were using at port number 500, but today we are using GDOI. So this is the command for the same. Okay. So this is done here right now. And after that, try to ping between these loopback between these here. This one. And ping with, now check it here, show crypto IPsec SA. Nothing is there encrypted because we haven't generated any packets. Ping. With 10.4.4.4 as a source of 10.3.3.3. So crypto IPsec SA. Packets are getting encrypted here. Okay. Okay. We are using what? ESP. Okay, guys. Is this clear? All clear? Now, what was the CMD used for registration verification? Just normal show crypto details. Show crypto GUI details with this. Okay. Two commands. Now, the very important part. Okay. Let me take a snapshot of this, or let me just not snap. What is that? Snipping tool. Copy. Let me paste it. Okay, and in this one, I think somewhere I have, in this document, I have one more capture. Some captures I have. Okay, let me check one. Let me check it out. One or two captures, guys, which is without any this one. IPsec, is there any IPsec here? IKV1 captures. Let me open it. This is ESP. Okay. So guys, see. Is there any AH into this? AH is not. Okay, fine. No problem. So let me just get back to this. See guys, right now, see, This is the one of the captures from my previous saved captures and all. This is the one of, okay, snapshot from this. So this is the topology there, which they are using it. And here, both the devices, they are using IP here 10.1. They are using as a 10.2 here. And behind that, they have some LAN, which is like considered as a 1.1 because the traffic is encrypted. And this is about 2.2.2.2 here. And we are using IPsec into this. So when we are using IPsec here, so now what would be the header? Let's consider I'm doing a ping from to the 2.2.2 as a source of 1.1.1.1 here. So as per IPsec, whatever we have learned earlier, so let's consider first of all ICMP data, and then this is the header here. We have different information. So this is about ICMP header, ICMP data. Okay. Then we have ICMP header. This is about ICMP header. This is the which one? ICMP header here. After that, we have inner like header here, which is source IP and destination IP. Then we have ESP outer header. Okay. So here, this is the source IP, destination IP, but this header is all about inner header, or you can say actual source and destination. So in actual source and destination, what would be the source IP, which is 1.1.1.1, destination 2.2.2.2. After that, we have ESP header. Then we have source IP, and we have destination. So this is about outer header, or you can say here public header, and this is the private header. Okay, so this is about now source IP. So source IP is what here? 10.1.1.1, and consider that is 10.1.1.1. Right now, I know this is the private IP, but it would be considered as a public IP because I'm using this concept here. So guys, this is clear or not? This concept is clear? Yes, guys, is this clear? In this one, just kindly consider 10.1.1.0/24 as a public network. Okay. So guys, see, in ASP, as you know, all these things are encrypted. We won't be able to see anything. Okay. That's the reason in this header, we can just see outer header here, which is the public header, but I cannot see inside header here. So see, but actually, you know, who's the actual initiator of this 1.1 and 2.2. This is in the normal IPsec. But if I'll come back in this one here, guys, you can see what is the loopback. Loopback is this, but what is the outer, what is the public header? 12.3 and 13.4. But can you see in outer header also, we have which IP? Only, or you can say this is about the this statement is clear or not? Is there anyone in this batch who has a doubt with this? Instead of public, which we have the private only, which is the actual, because actual source is also, because I have pinged what? I have pinged from like to 10.4.4.4 as a source of 10.3.3.3. So the same IP I can see in the header. Yes, guys. Any doubt? I hope this is clear. What is the difference between both here? Because this is about what? This is outer header, which is this is the public header. Public IP. But here we have which one? Private one. So this concept is known as here IP reservation. This is known as IP preservation here. So I'll take you to IP preservation concept here. Now, IP preservation enable encrypted packet carry the original source and destination IP address in the outer header rather than replacing them with the tunnel endpoints. Because what are the tunnel endpoints? Say the tunnel endpoint is 12.3 and 13.4. But rather than that, okay, it's what using what? Your actual source and destination, which is what? 10.3 and 10.4 here. Actually, in the outer header, there should be these two values should be there, but actually that is not there because these are the tunnel endpoints. That is not there. But what is there? Actual source and destination. Okay. This technique is known as IPsec tunnel mode. This is also known as, guys, IPsec which mode? Tunnel mode here, which is known as tunnel mode and address reservation. Okay. After that, I'll take you down here. So what is the advantage of copying? Because right now what we are doing, we are copying the inner header into the outer header. Okay, because this is the kind of like now inner header information, which is the actual source and destination we are copying into the outer header. What is the advantage of this? So the advantage of copying the inner header to the outer header is that the network can route the packet based on the actual destination and find the best path to reach the destination. Okay, so we do not have to just use any public here. So we can just use the direct what? We can use the you can say the actual source and destination. So my VPN can find out the best path and it would be faster also, because let's consider in case if you're using a public IP, in case if you're using a public IP and this is connected somewhere via ISP and all. So first of all, the packet would goes to this and then it would be come back to this one. Okay, for example, this is the one of the small topology here. Now I think it would be easy for you. This is my ASA. Consider this is ASA, ISP, ISP. Now key server here. Okay. Group member, key server here. Connected with the switch. Consider using the public IP 12.1, 13.1, 11.1. This is the key server one. This is the group member one. This is the group member 2 here. Okay. So now, and there is a LAN, which is they are using something 10.1.1.1, and here they are using LAN 10.2.2.2.2 here. So what is there in outer header? Which information will be there in outer header? The information is about 10.1 and about 10.2 here. So what happened? In outer header, we do not have their public IPs here. We have a private only, so they are be able to route what each other inside the network. But let's consider instead of using this, you are using the normal IPsec here. Okay. In that, we would have the public IP in the outer header where it would be 12.1 and all about 13.1 here. So then obviously it would goes to the like this way, then would be come. Because it's all about the public network. Okay, so what is there? That would be faster and it would be easy for that time for the device to find out the actual destination. So the advantage of copying the inner IP header to the outer is that the network can route the packet based on the actual destination and find the best path to each destination. One advantage, however, it's that you cannot use address preservation on the internet. Okay, because this IP preservation can be used inside the private network only. That private network can be your LAN or can be your MPLS. Okay, so you cannot use address preservation on the internet since private IP addresses are unroutable here. So it's a incompatible with the NAT. So this is the reason in the GET VPN, there is no involvement of the NATing, and NAT make changes to the outer IP header, and that I do not want it. Okay, so this is the IP preservation concept here. Okay, which makes it differ from the normal IPsec which we use over the public network. Clear? So Get VPN would provide centralized key management on the key server, okay, from where we would manage all the keys like TAC and CAC. And along with that, it would provide us IP preservation, address preservation or IP preservation concept. Okay, that's it for the day. After that, we have to start with the keys, rekey concept here. So today we have, even we have not seen any unicast also. So today I'm not I'll not get into that. Okay. So you have to do it. We will do it tomorrow here. Okay. So I'll save all the configuration along with the key server app. So this is right on the key server here. I'll write the configuration on group number 1. That is done. Group number 2 here also. Let me write the configuration. So tomorrow when we'll start the lab, so it would start from the same point itself. So no need to configure it again here. So first tomorrow we'll see the rekey with the help of unicast, and after that we'll go with the multicast concept here. And I'll try to finish your course. So tomorrow the target is rekey as a unicast, multicast, and then along with that. So tomorrow I'll try to finish your Get VPN. This document I have already uploaded on your drive, okay, which you can refer during your practice. Okay, guys. So now tell me, is there anyone who has any doubt, any questions, anyone? Yes, guys, only Santosh has acknowledged. What about other students? Any doubt, any questions, anyone? Benita is clear. Okay, Pawan clear. What about other? Shani, Sushil, Vincent. Okay, all clear, right? Okay. So guys, then see you tomorrow. Okay, and we will continue tomorrow. So, and do not miss your tomorrow's lectures. Okay, because tomorrow we would learn how to share a private key. Because up to now we have seen that we can just share the public keys. Okay, we cannot share the private key. But tomorrow we would discuss how and why to share the private keys. Okay. So I'm done. So shall I close the meeting, guys? Any doubt, anyone? All clear? Good. Then guys, see you tomorrow. Okay. Bye-bye. Take care. Have a nice day. Thank you.